And welcome to Cornerstone Home Inspector Education Center. Tonight we have Stan Poderski on structural support columns. Take it away, Stan.
First, I'd like to thank everybody for attending. Tonight we're going to talk about something that we may take for granted sometimes, but structural support columns, we see them in almost every home. So we're going to talk a little bit about them tonight. Oh, I can control this today. All right. So support is everything. Residential homes have been supported for hundreds of years by columns consisting of a variety of materials. This presentation will discuss the various materials used for support columns that we as home inspectors will typically come across, as well as their potential defects. Column material: wood, brick, concrete blocks, steel. There's generally two kinds: concrete filled and the adjustable.
Stan, hold on. Raymond, you need to mute your microphone.
Will guide us. And
Raymond, please mute your microphone.
Got it.
Thank you. Go ahead, Stan.
And then potential defects and damp rising, which is a term you might not know, you may know. We're going to talk about that in a little bit more detail towards the end of the presentation. So a column for our purposes is defined as a supporting pillar, especially one consisting of a usually round shaft, a capital, and a base colonnade of marble columns. Well, they're not all like that, but that's what the definition is. And ancient Greek architecture came from the Greeks or Hellenics, whose culture flourished on the Greek mainland, and their architecture was pretty dominant with columns, as you can see here. They're decorative, but they also serve the purpose structurally. There's three orders of Greek architecture: the Doric order, Corinthian, and the Ionic orders. They were all heavily into ornate columns, so they date back quite far. All right, why is this not moving now? Jim, am I locked up here?
There you go. Try it now. Try your keyboard.
That's what I'm using.
Okay. There you go.
I got it. Hold on. Let me make sure.
Yeah, you're good.
Yeah, but I got to go back to where I was. Hold on.
There you go. Go back the other way.
Am I going the wrong way?
Yes, go back the other way. There you go.
Holy shit.
So, yeah.
Sorry, guys. Going the wrong way.
There you go. So just click forward a couple.
Why is my keyboard not working?
All you're going to do is use your little arrow. There you go.
Okay. Here's some pictures of the columns back then. Three different types there. Today, we mimic these columns somewhat on the exterior and interior of homes in America. Interior columns, a lot of these are probably structural, lined up over a girder in the basement. Others are just there to create the pattern that or architecture that they're looking to simulate. We've probably all seen some similar to these in the early 1900s houses with the archways and openings. And back then, those weren't really exotic houses. They just put a lot of these things in there to carry over the old-time architecture. Wood is one of the longest standing building materials in existence, with evidence showing homes built over 10,000 years ago using timber as primary source for construction material. Europe's Neolithic longhouse, a long, narrow timber dwelling built in 6000 BC, is an excellent example. As one of the largest buildings during that period, the Neolithic longhouse was solid and massive with a capacity of housing around 30 people. And this was all supported by wood columns and wood timbers. And we'll see in early homes a lot of wood columns. Sometimes they have been replaced or working with replacement columns or additional columns. here are some of the originals in this house. They were just timbers, bark taken off and slapped into place. And they probably still are functional. I still see them a lot in some of the beach cottages that I roll under here on the coastline in Connecticut. They're usually cedar, and a lot of them are still in place, believe it or not. So we as home inspectors see wood columns in homes built into the 1930s. Many are the originals and are faring well. Most concerns for wood columns deal with moisture and insects. If the base of the columns begin to rot due to chronic dampness or seepage, they will compress and the structure will follow. Insect damage can compromise a wood column as well. If I had to guess, I probably see more decay problems with wood columns than insects. I do know I've seen insect damage to columns more in crawl spaces than basements. While the majority of wood posts are still functional, many inspectors advise that they be replaced with steel lowly columns. I would have to see the condition of the columns and the structure to decide if I wanted to make that recommendation. I'm going to say probably 80% of the time they're going to have some type of water staining or dampness staining on the bottom. So you got to probe them, see if they're solid, and then go from there with your recommendation. Versalam columns, laminated veneer columns manufactured by Boise Cascade. They are highly suitable for wood columns. They have the same properties that make Versalam beams great. They are free of deep checks, cracks, or twists that can plague solid wood columns. The allowable axial load for the Versalam columns vary depending on the size of the column and length of the column. You can find more information on Versalam columns on the Boise Cascade website. So several years ago now, Scott and I got a call from a realtor that I worked with who manages a few properties as well. Her buyer, her owner now, lives in Florida, and there was a rental property in West Haven, and one of the tenants said the addition was falling, and she asked me if I would go take a look at it. So Scott and I did. So there was an addition off the side of the house, 2-story, and it did appear that the floor joists were pulling away from the main. Actually, it wasn't even a girder; it was the sill box that was the original part of the home. So we decided to build a girder under those floor joists, and we used an engineer to spec out everything for us. And he chose these guys as the columns. We had 3, I believe, across the length of that house, or it was 24-foot span, and we put 3 columns up. I believe Scott probably is Scott here? No. We had to waterproof the bottoms with a rubber membrane and keep them out of the ground with the concrete footings that we put in. And we brought all this to the local building department for approval, and there was a problem. The engineer put for the concrete 300 pounds, and it was supposed to be 3,000. And the building department, the inspector, refused to sign off on the drawings, and he told me why. So I took the drawings and I put an extra 0 there and turned them around and pushed them back to him, and he said that's not acceptable. You have to have the engineer make that correction. And I said, I said it's going to cost more money for this woman, and I don't even have to get a permit. I can do this job without a permit. And he approved it and gave it back to me, and we put that all in. So and it wasn't the beam he was concerned about. It was the strength of the concrete, which was just an error on the engineer's part. So sometimes you have your way with the building department as well. You don't get in their face, but you kind of tell them where you're coming from. So concrete block I see a lot, especially in crawl spaces like this, and they usually look pretty suspect for the most part, and they are built up usually with different sizes of block and then wood shims because of the varying heights of the floor is never level, so they're always going to be different. That's another thing that you have to kind of look at, and you have to get a feel to think if that's going to be substantial or not. How old is the house? How long has this been here? Concrete block columns are used as load-bearing components inside the perimeter of the home. These columns are usually made of concrete masonry units. We commonly refer to them as concrete block or cinder blocks. The lifespan of concrete columns can vary depending on the type of the concrete used, the quality of the installation, and the environmental conditions they are exposed to. Precast concrete columns are designed to have a lifespan of 50 years. However, the lifespan of concrete masonry units used in older homes can be much longer, up to 100 years or more. It is important to note that the lifespan of concrete columns can be affected by factors such as moisture, temperature, and exposure to chemicals. If you have any concerns about the structural integrity of your concrete columns, it is advisable to consult a professional contractor or engineer. So that's something that we also do, right? We recommend that when we're not sure of how things will fare. That picture on the bottom is just sistering that original wood column with a block column, and you can't really see it, but there's brick at the top of that to take up the space where the columns didn't reach the girder. Steel lally columns. The most common column in modern construction is the lally column. A lally column is a type of structural support column that is used to provide support to beams or timbers stretching over long spans. It is typically made of thin-walled steel and filled with concrete. Lally columns can be used temporarily to hold up extremely heavy structural weight when performing other repairs, such as major wall remodels or installation of new windows or doors. Permanent lally columns are sometimes installed to correct structural problems as well. The oldest form of lally column is a non-adjustable steel column cut down to size and filled with concrete. However, the term has come to encompass many other iterations of mobile steel columns. Adjustable steel columns, telepost, jack post. Adjustable columns consist of two telescoping steel tubes, one inside the other, that adjust upward or downward to temporarily or permanently support an unsupported joist or beam. There are also three-piece as well. These are just a stack. You see the different sizes that you can buy. You can buy one big long one, cut them down to where you want. They're not easy to work with, and you better be precise when you cut those down if you're installing them to replace an existing column. The wood was easy to work with, the lamb beam. Lally columns have an alter ego. Lots of people refer to them as lolly columns. And this post was invented in the late 1800s by John Lally in Waltham, Massachusetts, as a fireproof, insect-resistant means of supporting buildings at their very lowest points. It was intended to be filled with concrete and installed for permanent structural support for loads up to 44,600 pounds. That's a lot of weight. So now a lot of people call them basement columns, although they're not always located in a basement. The basement columns are there to support the dead and live weight of the internal parts of your home above them. You might not realize this, but basement metal columns hold tremendous loads. A 4-inch steel column at 6 feet in height can support more than 20,000 pounds, which is a lot of weight. That weight is the dead weight of the flooring, the floor joist, and the joist girder beam, plus the live weight of furniture and the house inhabitants. The load of the floor goes to the joist, then from the joist to the joist girder beam, and through it to the basement beam and into the foundation and the walls. So if you are viewing this after as a pre-recorded webinar, you need to submit this code SC164924 to us in order to get your certificate. There'll be another one coming up down the line. Lally columns rest on the concrete footing. So you guys know, I'm sure, There's footings under the perimeter wall of the foundation. There's also footings or pads under each one of these columns. And that's why sometimes if this was sagging here, you're going to put another one there. It's probably best to cut a hole and foot that the same way. If you're temporarily supporting on either side of this to take this guy out and put another one in, you don't obviously need those footings because you're going to remove the other two after this one's put back in. But there are footings, or should be, underneath here. The basement concrete floor is poured over it after the installation, and the footing is thus encapsulated. This way, lasting structural stability of the Lally column in place is achieved. Permanent post, support post, a permanent column for permanent structural support. This Lally type is a non-adjustable fixed height concrete filled basement support post. This type is stronger than the other two Lally types, and because it's a fixed length, it's better suited for permanent support applications. To secure the column to the beam, a beam plate at the top of the column is used. There is an end plate at the bottom to prevent any lateral movement. I rarely see end plates installed. Most of the time, I'll see these guys embedded in the concrete. So they're set up first and then the concrete poured afterwards, like this
Dan,
one here.
I have a question. You
Yeah.
go into a lot of older homes, you'll see the Lally column at the base just sitting on the concrete slab. You know there's no footing underneath. Do you call that out?
How do we know, though? I mean, you may want to mention it.
Just so
You mean
it's an
the permanent? I mean, the original one or an
no.
added one?
So you go into any older home, like I'm talking like 1850s, anything pre-1900, and or three family in Hartford, Newington, or in New Britain. These older three families from 1900. Someone's gone in there, maybe the floor is dipping, the beam sagging, and they'll throw a jack stud or a Lally column, and they just secure it to the top beam, but they'll just let it rest on the concrete on the floor. You see it's not going through.
Okay, yeah, I understand. So I think you would have to kind of figure out how much weight is on that part of the, because don't forget, if you have two other ones, they're probably taking up most of that weight. You're putting one in the center. Is that what you're saying? Like where it's sagging?
So basically, you're calling out no footing. You're just saying that beam is resting on concrete slab. That footing's not going anywhere there's no footing there supporting the weight. It's just the weight of the concrete floor. That's supporting the Lally column.
All right, if you're putting it underneath here,
right? And so
Maybe
if you follow that beam all the way to the floor, and at the base, right. What if there's no footing underneath there? It's just 3 inches of concrete. I see that all the time.
I mean, that's a tough call, but I don't think there's as much weight here because these two guys are picking it up. Now, if you're putting it under a floor joist that's sagging, I would say you don't even have to worry about it. Under here, it's probably not a bad idea, but I wouldn't use a jack column here. I'd put a solid one here on a footing. That's what I would do.
Okay.
Follow me. It depends on what you're trying to hold up. If a floor joist is sagging, there's no weight on top of that floor joist. There isn't a piano that's causing it to sag. It's probably not going to affect the floor.
Right.
So if you're just trying to push up a floor, you probably don't need a footing.
Gotcha. Because you're in a basement. My understanding is that you don't have to worry about freeze and thaw. So you don't have to go 48 inches like you would for a deck outside.
No, it's just a pad. It's just a pad.
Okay. All right. Thanks.
Just like this. This is a bad example. I couldn't find a better one. Doesn't really give you any depth or dimension, and it looks like it's offset, but it's the only picture I could find to kind of depict what we're talking about. This is where the columns would go, I'm guessing, in this. Because if we don't have something to hold them up, you'll drive them down.
Right.
So if the Lally column is rusted, it can lose about 1/3 of its strength, according to structural engineers. If the rust is light and superficial, it may not be structurally significant, but it could indicate humidity in the basement or crawl space. A professional can scrape and wire the brush, a professional, and take the flaking off first and then seal it with a rust inhibiting paint. If the rust is severe, it is advisable to replace the Lally column as soon as possible. If the concrete is exposed, the column should be replaced. So I kind of live by that. If I see concrete exposed at the base of a column, I'm writing up that that column has to be replaced. Okay, a little bit of rust is not a big deal, but why is that rusted? So this is in a garage. You can see the car. So water, snow melt, probably hitting that column all winter long, depending, or even summer if it's water. At least you know what the source may be here. But I'm sure well, I've got a picture, so we'll wait until we get to that. So here's a column. This is about 4 feet up off the ground. This is rusting. There's water. Water was actually seeping out here. Here's another similar type of situation here. So that basement was relative. I mean, if you walked on that basement and you're looking for evidence of dampness and seepage, you didn't see much there. But where is this water coming from? It's being wicked up from underneath that slab. All right. So is this going to continue and become worse? Now, unfortunately, I don't remember how old that house was. So how are we supposed to know that? How do you want to write that up? If it gets worse, replace it. One way to handle that, if you think moisture's under that slab, is put a sump pump in and try and collect that water and pump it out. But then don't you think you'd see water efflorescence someplace else as that slab got wet? So these kinds of things are a little tricky when you see them, as to determine how that water got up there, but it's definitely wicking. And this is just pretty bad right there. So damage during installation. Somebody sledgehammered this thing to get it into place, it looks like. And that's a failed column. It's not supporting 100%. That should be replaced. Other concerns besides rusting and damaged columns, spacing of the columns. So typically a steel column is placed every 8 feet on center in a wood frame 2-story residential home. I used to think that they were all supposed to be under a splice, but when you look at some of these, the splices are offset. And you also, if you support it at the wrong spot, the wood can kind of lift. So you also need to be resistant to bending that splice upwards as well. It's not a big deal, but it'll be a little hump in the floor. You may feel it as you walk through the house. Now, I don't know how many times people find steel Lally columns problematic unless they're badly rusted, but I see adjustable columns a lot. And if they're under, like I was talking with Jim before, underneath the floor joist, or an area like if you walk through a dining room and they have a china closet. So I'm a big guy. When I walk through a room that has a china closet, those 2x8 floor joists are shaking the shit out of those dishes. It's not a structural issue, because I mean, if you wanted to do the calculations, that 2x8 was probably fine, but every floor joist is weakest at its center, and it's going to vibrate. So you can put a couple of these underneath there if you don't mind compromising the open space of your basement, and it'll take that vibration out. But when you're supporting the house with one of these or several of these, then the concern develops. So telescoping columns designed for use in the United States, also known as teleposts, sectional columns, double section columns, jack posts, or jacks, should be reported as temporary columns that should be replaced with permanent columns. Telescopic adjustable columns are regularly used in construction to adjust or level structures before installing the permanent column, or they're used as temporary supports during the course of building repair. No telescopic adjustable column has been evaluated by a U.S. evaluation firm and none of their manufacturers cite an engineering report to prove these columns' ability to carry a specific load. They're basically a tool. Also, according to the IRC, a steel column has to be at least 3 inches in diameter. All telescopic columns are less than 3 inches in diameter. You must therefore assume that these adjustable columns are not designed for permanent structural use. And I have pictures at the end that'll show you what can happen with them. But if this isn't 3 inches, this certainly is not. And that's what we're supporting. This was one story here, I think, in this house. And I believe this was a very old house. There was wood here, and there was a couple wood left back here too. So I call these out to be replaced. Now, does it mean somebody ran down there when they got out of the moving truck and replaced them? Probably not. They're probably still there. So here's the 3-piece. Here's the 2-piece. This just unscrews. A lot of guys put this screw part in the bottom. They want this bigger part up at the girder. This is 2 pieces here, and then this screws up. So they're 3 pieces. So there's a lot of places where, and they're hollow, obviously, a lot of places where things can go wrong. Adjustable Lally columns are easy to use as they simply slide in place and adjust to fit the space. Can't be any easier. Adjustable columns typically range from about 3 feet to 14 feet tall. The shorter the column, the greater the weight it will support. For example, a 6-foot-long, 4-inch diameter column has a maximum weight rating of 21,300 pounds. Increasing the length of the column can drop its weight rating to 10,000. Non-adjustable steel columns require more prep work as they must be cut to fit within a given space. During remodeling, when an interior load-bearing wall is removed, a series of Lally columns will be put in place of the remove wall to keep the house structurally sound. These posts will later be removed when the wall is rebuilt or another type of bracing is installed, such as a beam. Short jack posts are often placed in crawl spaces and basements to correct sagging floors. Temporary projects that need quick shoring up and easy removal. I'm sure we've all seen them in place permanently. There's a development here in Connecticut. Their ranches, they're probably fine. They were built originally with them. They were kit houses. Some installers place screw jacks or teleposts with the screw down against the concrete floor or pier top. That allows the larger diameter post bottom to be placed up against the steel plate and against the underside of the beam. The upside down installation reduces the chance of bending the steel support plate. It also places the thick steel screw down on the often wet basement or crawl space floor. The thicker steel screw is slower to rust through to the point of collapse than is the thin-walled hollow steel pipe that forms the body of most teleposts. So there's a method to their madness. So potentially defective conditions. The post is less than 3 inches in diameter. According to 2012 International Residential Code, columns, including adjustable steel columns, shall not be less than 3-inch diameter standard pipe. Poles smaller than 3 inches violate the IRC, although they are not necessarily defective. A 2.5-inch post may be adequate to support the load above it, while a 4-inch post can buckle if the load exceeds the structural capacity of the post. So everything needs to match up. Structural engineers, not inspectors, decide whether adjustable, and I believe they're talking about municipal inspectors, not us, although we're probably included in there, decide whether adjustable steel posts are of adequate size. The post is not protected by rust adhesive paint. All surfaces inside and out of steel columns shall be given a shop coat of rust adhesive paint, except for corrosion-resistant steel and steel treated with coatings to provide corrosion resistance. Inspectors will not be able to identify paint as rust inhibitive. In dry climates where rust is not as much of a problem, rust inhibitive paint may not be necessary. Visible signs of rust constitute a potential defect. The post is not straight. According to some sources, the maximum lateral displacement between the top and bottom of the post should not exceed 1 inch. So what they're saying is there is some acceptable leaning, believe it or not. However, the tolerable lateral displacement is affected by many factors, such as the height and diameter of the post. The post should not bend at its middle. Bending is an indication that the column cannot bear the weight of the house. I would say that's true. The column is not mechanically connected to the floor. An inspector may not be able to confirm whether a connection between the post and the floor exists if this connection has been covered by concrete. The column is not connected to the beam. The post should be mechanically connected to the beam above to provide additional resistance against lateral displacement. More than 3 inches of the screw thread are exposed. There are cracks in upstairs walls. This condition may indicate a failure of the component. So cracks can develop by pushing up on them, and they could also develop by sagging. And if you are inspecting a house where the primary support are these columns, then you really should be, before you make a definitive comment on them, I would look around the rest of the house and see if you see anything else that's indicative of some kind of, doesn't need to be a critical structural failure, but sagging and things of that nature that will help you make the call a little bit better. So this is a house I did, I don't know if last year, maybe 2 years ago. This is in New Haven, Connecticut. It's a 4-story. This is an 1870 row house, 4 stories high. So the 3 stories you see there, and then the one that you barely see is the first floor, and then there's a basement under that, believe it or not. All 4 columns, they were brick, have some degree of deterioration at their bases. If deterioration continues, the load-bearing capacity of the columns can be affected. As a matter of fact, they can already be compromised. So if you look at this column here, the brick is essentially disintegrating. The mortar joints are gone here, but the brick is really in bad shape here, and they all were similar to this. Here's another one. If you have been in a home inspection business for any length of time, you have probably inspected an older home that had brick columns supporting the main carry beam of the home. The base of these columns can be affected by moisture and humidity in the basement. It is not necessarily the result of seepage, but the mere presence of moisture over a long period of time. So if you're viewing this as a pre-recorded event, you need to record this code SC304924 and submit it to us when you are submitting for your certificate. So what we saw in that picture, is that spalling? No. Spalling is defined as break into smaller pieces, especially in preparing for sorting. This is spalling, where the brick is actually, looks like it's sliced, it's in pieces, chunks, so to speak. And spalling can happen anywhere. It can happen on a chimney, up on a roof. It could happen in a brick wall. And if the moisture is not stopped, it's very destructive. But there is another similar type of situation, and it's called rising damp or salt damping. And it's a noun, it's British. It refers to moisture absorbed from the ground into a wall. And it is more of spalling is more of a flaking or slicing effect. It is caused by moisture absorption and can occur at any level in the brickwork, even high up in a chimney. The disintegrating of brick, like this in those previous pictures, is likely caused by salt damp or rising damp. As porous masonry absorb water from the ground, it is also absorbing salts. Salts are harmless underground where they stay wet and stable, but above ground, when the moisture evaporates, they crystallize and harden. They increase in volume upon hardening, at which point they cause damage to the brick from the inside out. This type of damage is usually at ground level, as in these column bases, and can rise above the ground about 1 meter or approximately 3 to 4 inches. So one may ask, is efflorescence salt damp? It is an external alarm when present on brick surfaces that salt damping is likely occurring at some level. On its own, efflorescence doesn't damage brickwork, but it is unsightly and can indicate a deeper problem. It can also cause damage to things like external masonry paints. The salt can cause paint to bubble and flake. When efflorescence is clearly visible on brickwork, this means there is an excessive moisture in the masonry. This can cause separate problems that can be more severe. Rising damp can affect wood, sheetrock, and other materials, and is often misdiagnosed as normal penetrating moisture damage. So we're off column thing, but I just want to get into this a little bit more. So rising damp is caused when groundwater travels up to a building materials of a home. The capillary action is usually stopped by a damp-proof course. In this picture, there's felt paper put across here, and that'll prevent it from going any higher. The damp-proof course, DPC, is intended to block the moisture that is rising through the capillary action. It should stop moisture before it reaches high enough to cause internal damage. This is usually slightly above the external ground level and below the floor level inside the property. If your damp-proof course is working correctly, this should mean the water is blocked at the point and can't travel any further. DPCs are made of different materials depending on the period of your property. In older properties, you will often find the materials such as slate were used. And even older property, you might find there is no DCP present at all. Finally, in modern properties, it's more common to see materials such as bitumen or a plastic damp-proof course. You will usually be able to see this externally on the external walls, roughly 150 centimeters above ground. So this is a different material here, but that's the same approach in a modern construction. So what do you tell your clients when they ask if this is a major structural issue? This is a 4-story building. Yes, it is. They are smart enough to know that these columns are holding up the home and clearly are in less than optimal condition. In this case, the home is 153 years old, 4 stories high, with no obvious structural distress related to the condition of these columns. I'm going to tell you that that building, at least the part I was in, was level, straight as an arrow, plumb. Those columns weren't structurally deteriorated to a point where they were affecting the building. If the condition continues, however, the structure can be compromised. So it took 150 years to get to that point, but I'm not walking out of that building telling them they don't have to fix that. So I said they needed to have it repaired. What's the fix? So the question is, can this be repaired and how? Remember, the damage in question is at the bottom of the column. Can the base be cleaned and reinforced with concrete? Can we skim coat it, fill in the mortar joints? Can we chop out bricks and put them back in? Like this guy's doing here. Most of them are already out. Can a steel column be installed on either side of the columns? I always tell people that they need to have an engineer determine stuff like that. So the buyers in this case had a mason come out who essentially recommended the installation of a steel reinforced brick column. So what they were going to do is something like this. They were going to put a steel column in and build the brick around it. So I couldn't tell you, and I don't think anybody that's listening probably has a good idea of, can the column hold up the house by itself? Is the brick going to have to be built to assist the column? Is the brick being built just to match the other columns? To me, that's all the job of an engineer. So when I asked them if the mason consulted a structural engineer, my client said no. So I never heard back from them. I don't even know if they bought the house. This I did earlier this summer, a house in Weston, Connecticut, where the garage wall, a block wall, was bowing in a little bit. That's where it was. I don't know what this catastrophe is here. That was doing nothing to the house, but the soil, there was a retaining wall here as well, was pushing against that garage wall. So this is essentially what you have here. You have some pressure pushing up from the ground, pressure pushing down from the house. The soil was pushing against the wall and blowing it out. So columns can be installed to hold that wall back. As you see in these two pictures, these are two different situations, but they're like buttresses and they are put in footings with steel rebar here, two pieces actually, and they should be able to hold these walls back. Again, engineered by an engineer. In this case, though, in the house I was in, this is what somebody built. So they built this cage. There's a girder going down here, and then this here wound up over here against the wall with another girder against the wall to take the pressure off the top of the wall. Massive footings. I can only imagine what was inside here to support these guys here. But bear in mind, let me go back if I can. It was only up against this part of the wall. This wall, to me, is still susceptible to this pressure here. That's why these guys are pressing against the entire wall. That's a better fix, in my opinion. So I wasn't really comfortable with all this. But I told him, I said, you know, it's best to get some kind of engineer report on what the theory was behind here. And I know that fellow bought the house. I know that for a fact. So this was in another presentation we had, but I want to go through it again because it has a bunch of columns in here and they basically all failed. So this house was a 3-story house built in the early 1900s. There was double girder, one here and one here. The first support for these girders were wood columns. Let me get to them. They were on, the one was still in place. It's shot at the bottom. I don't know why they didn't knock it out. This one fell over and they just left it there. It was disintegrated. Then they put steel columns in that are starting to rust at the bottom. This one was the worst. The weight of the house was actually driving the column into the girder. I couldn't tell you how deep it was in there, but if you walked above here, you can feel the sloping. And where are the there should be a picture in here. So then they decided to support the steel columns, which, you know, look, the rest are still in good shape, with some jack columns. I don't know if you can see here. Can you see how this is scissoring? Here, this guy is kicking out from the weight of the column, and it's having a scissor effect. So these guys are even failing here. The girder's twisted. Now that girder is a solid piece of wood. It probably twisted on its own. I don't think it's from the stress of the load of the building, but all this really kind of is compromising the structure here, in my opinion. Then there was rot, and this is sagging here. There was a lot of mold, a lot of water damage to wood and the joists. So these are the kind of things that you really need to look closely at everything, because there was more than just the columns in that building that were an issue. That was an investor who was sitting poolside in Florida drinking a Mai Tai while I trudged through that wet basement and collected information for him and reported back to him. I'm not sure if he bought that house or not. But you know, we take a lot of this stuff for granted, and I got to think a lot of guys probably, as long as that column looks straight, and there's no issues in the house, they probably don't give it a second mind. But look them over, make sure you think they're doing the job they're supposed to do. I'm sure everybody already has a way to handle all this stuff that we talked about, the adjustable jack, stuff like that. But so in summary, missing structural columns or post footings and piers. Sometimes the builder may omit installing necessary columns or their associated footings and piers. Detecting these omissions is crucial to prevent foundation failure or damage. Proper bearing support at both the top and the bottom of the columns is essential to avoid structural collapse. So finding or determining a footing is missing, or a pad is kind of difficult, I would say, unless there was evidence of it. The concrete is cracked or settled. Missing columns, if you walk in a basement and there's two and it's like 40 feet long, you're probably missing a column. I'm sure the girder is going to be sagging. Improper use of temporary columns or jacks. Temporary columns, also known as teleposts and jack posts, as we said, are often used during construction for remodeling. However, they are not designed for permanent support. I'm hoping that we all know that by now. I don't know what they teach now in these classes that everybody's taking before they become a home inspector, but I hope that's part of it. If these temporary columns are left in place, they can pose a risk of collapse. It's crucial to replace them with permanent columns when needed. So that's probably the best recommendation if you see them. And then steel columns can rust over time, especially if they're hollow rather than concrete filled. Rust weakens the structural integrity, increasing the risk for failure. I think that's the last, one more, okay. Insect damage to wood columns. Check wood columns for termite, carpenter ant, and powder post beetle damage. Moisture damage to masonry and wood columns. Check masonry columns for evidence of deterioration due to moisture. Check wood columns for decay. Connection failures. Pay attention to the connections between the columns, beams, and piers. Connection failure is often a weak link in residential structures. Properly designed and secured connections are crucial to prevent movement and collapse. Choosing the right steel column. When selecting steel columns, consider factors such as load-bearing capacity, material type, and intended use. Two-piece telescopic posts are not suitable for permanent support. If used as such, they should be replaced with permanent columns. So we're a little early. Anybody have any questions about or any comments they want to add? Any personal experiences that they've come across regarding columns, defects, the telescoping columns? We got to kill at least 5 minutes. Anybody got a joke?
I have a question. So what if you go into a house that was built in like the 50s and it has they put those permanent columns in when they built the house, but they look in great condition?
You mean
the jack columns?
Like they were original to the house. Yeah, the jack columns. They were original to the house.
So I'm going to tell you that I've seen those. Probably 50s or 60s. I think they were kit houses after World War II, but I'm not sure. So they were ranches. And like you're saying, the columns look fine. You walk through the house, there's no sagging, there's nothing going on. And in that case, in that development, they're all secured to the floor and to the girder.
Yeah, so, they're embedded under the concrete.
Or right, they could be. So here's the thing. Back in a couple slides ago, they said that one of those columns could hold up to 20,000 pounds, which was the equivalent of a steel column. If you remember, those were at 20 to 30,000. If you only have a one-floor structure, they're probably fine. But you still have to decide, a lot of what we do, at least me, is I don't want potentially future crap coming at me because I didn't mention something, especially if I knew it. So I develop language that says these guys look great today, but ideally steel, concrete fill steel alley columns are the material of choice, and you should consider replacing these with those. So this way, You didn't say it's going to fall down. You didn't say it's not. You give them an opportunity to think that over. You told them what was better, but of course, if you see them, if they're rusted or bent, obviously that's a no-brainer, right? So sometimes the no-brainers are there. If you miss those, then you call your insurance company. But sometimes we got to be a little clever about how we proceed when something we know maybe shouldn't be there or shouldn't be used, but it looks fine. It's a hard call, but I think, I'm comfortable with the way I handle that by telling them there's a better way to do this and you should probably consider it. But that's me. I don't expect everybody to handle things the way I do.
No, thank you. I appreciate
I've
it.
only gotten down 35 years so far. I'm trying to get 2 or 3 more without making a mistake, and then I'm done.
How do you call out logs in old homes being used
I
as
do the
support?
same, Jim.
I'm sorry, what?
If it's not rotted at the bottom, I mean, they're not attached, right? Most of the
No.
time.
No. Toenailed in.
I'll tell them there's better ways to support these now. But it is what it is. It got through all those years without a problem. And now some Yahoo home inspector is going to tell me I got to take them out and put steel columns in there. I'm not going to be the one. So
Any
anybody else?
other questions? Issues? I guess not. Everybody wants to watch the election tonight. So
How much time? Yeah, we're good.
We're good. We've did 50 minutes, so that's what's required. Thank you for coming, everybody, tonight. It was very, very informative. I think next week we have basements in 2 weeks. And for Connecticut inspectors, we have our law seminar coming up, several options. So check out our website for calendar of events. We will have a Massachusetts law seminar, a Rhode Island law seminar, and a New Jersey law seminar. So we're doing pretty well booking out. Looks like we've got courses and stuff coming into April next year. So we've got plenty of content. And if you have an inspector friend who hasn't joined, tell them about us, and we'd love to get more members going. So thank you for coming tonight.
Yeah, and if you have a topic that you would be interested in hearing more about, just email us. If you have somebody, you run across somebody that you feel may be a good speaker and you know that they may want to give us a presentation, then either put him in touch with us or give us the name and number, and we'll pursue that. We're always looking for ways to bring in manufacturers and even installers, contractors, and mix it in with home inspectors' point of view so that we can get a good blend of our profession and the things that we work with. So we're always at your disposal. Give us a call, give us an email, and we'll see what we can do with that. All right, guys.
Thank you for coming tonight.